GDS2 is a very popular file format in the world of IC design. Every CAD tool can read and write GDS2. So importing data from a GDS2 file is a key feature for EZMod3D. Unfortunately, in most cases, the 2D data in the GDS2 file are insufficient, ambiguous, or even incorrect for using them as a 3D description. These data require a bit of processing to be ready for a 3D usage. This processing can be performed in the initial design tool or using a GDS2 editor such as KLayout, an open source tool that proved to be very handy for this. This demo will make use of KLayout. So the very first step is to install KLayout on your computer if you don't have it yet. The second step is to read the GDS2 file. Here we have a mom capacitor that we want to simulate with EZMod3D in order to extract its parasitic capacitance with respect to the surrounding. It is recommended to make your work copy so as to keep the original untouched. This is the case. This is already a copy. EZMod3D does not manage hierarchical structures, so the data have to be flattened before going further. So this is easy to do. We can flatten the cell down to any level of hierarchy. We don't need to go back. That's it. The next step is to merge the data, since sometimes we have overlapping polygons and things like that. So in order to simplify the database, it's a good practice to merge the layers. It is not the case here. The data are already correct. And finally, it can be a good practice also to snap the coordinates to a defined grid so as to minimize the size of the future meshed structure. A bunch of scripts can be supplied to make these operations easier. When we look at the data from the layer map table, we learn that layer 2 is the NWell layer. We will hide everything but the NWell. The concern is that the PWell, which is defined where no NWell exists, this PWell layer does not exist in the GDS, so it has to be generated. But before generating it, we need to define the PWell layer. This is easy to do. It's just to create a new layer, and let's say we call it layer 600. Okay. The PWell layer is just the Boolean inversion of the PWell layer. The problem is that to perform a Boolean operation, we have to operate between two layers to define until in which area this PWell will extend. Fortunately, in our case, we have already a box defined in layer 119, so we can create this PWell layer data by performing a Boolean operation. We will start from layer 119. We will subtract layer 2 by performing A and not B, and put the result in layer 600, and that's it. We don't need to be able to get back. And now if we look at the data, we notice that in our layer PWell we have exactly what we wanted to have, and we can go a little bit further. The next step, we will hide this. Next step is active or diffusion layer. present in layer 3 defines the places where silicon comes to the surface. And in the places where no diffusion or active data is available, we have a shallow trench isolation, but it is missing in the GDS. So again, we have to generate it. We will create a new layer. Let's say that this layer is 700, and we will perform again the Boolean operation between 190 and our box, our layer 3, layer active, and put the result in layer 700, and that's it. So again, we can see it. Now we have STI here in all these places. Now if we go a bit further and look at layer contact, which is in layer number 15, we notice that we have contacts on active diffusion, and we have contacts in places where no active exists. In fact, at this place we have poly, if we hide the STI. So we have contacts on active and contacts on poly, and all these two types of contacts lie in the same layer. The trouble is that when it comes to 3D, these two types of contact share in common their top z-axis coordinate, because it's just below metal 1, but at the bottom, active and poly are not located at the same z coordinate. So in fact, we have to split the contacts between two layers, one for contacts on poly, one for contacts on active. So let's say we will again create layers, 400 for instance for contacts on active, and another layer 500 for contacts on poly. And now we can perform again Boolean operations. It's just creating an AND operation between layer 3 and layer contact to put in layer contact on active, and a new Boolean operation between layer 15 and layer 13 poly to put in layer 500 poly contact. So now if we remove these contacts, we still have we remove contacts and put poly. Now we have contacts on active and contacts on poly that appear in two different layers. Now another missing data is that we have metal in this structure, we have poly, we have lots of stuff, but in the actual IC, everywhere in this on the top of the silicon block, we have oxide that lies everywhere and that defines the capacitance values between all the nets. The trouble is that usually in IC design we do not draw the oxide. So we need to define the oxide for the extraction to be correct, and again we will create a new layer. Let's say we choose layer 800, and we can fill it just with the box, in fact, this layer. So we will define that we perform again the Boolean operation between layer 119, 90, for instance, something like that, and push the result in layer 800. Okay, and now here we are. This will be our oxide layer.